Alright, picking up where we left off, we last spoke about the derivatives of functions. So you haven't watched that video, I highly suggest that you do. There was a lot of content covered in that, in addition to our first video on derivatives, the definition of a derivative. Now we're getting into a little bit more of the rote procedural, computational aspect of a derivative. So for the purpose of this video, we're going to talk about the product and the quotient rule. The reason why they exist is up until this point in time, we've only been deriving individual functions. X squared, a sine of x, the exponential. But what happens in the event that we have two functions, right? So, but two functions tied together using multiplication, right? Not separate by addition and subtraction. So let's say if f and g are differentiable functions, then their product is also differentiable, and the way we compute is we take the first function and multiply it by the derivative of the second, and we take the second function and multiply it by the derivative of the first. Now, does it matter whether you do this first followed by this? No, because we have addition, and we should know that addition is commutative. So let's say we were tasked with finding the derivative of x squared times e to the x. We do two different colors to help out you visual learners. If we have the first function, x squared, times the derivative of the second, we talked about in the previous video what the derivative of this function is, plus the second function times the derivative of the first. The derivative of x squared is 2x by the power rule, and that is it. If you want us to go ahead further and rewrite it as such, even factor out an x, you're more than welcome to. But remember, in calculus, we're not really concerned with arithmetic, so you don't need to go any further, because that is perfectly acceptable. So what are we talking about when we're talking about the quotient rule? Should have kept that intro part because I don't have to rewrite it. But nevertheless, the quotient rule is a little bit more complex. So let's say if f of x and g of x are differentiable, then their quotient is differentiable for all x such that g of x is not equal to 0, right? And this derivative is a little bit more complex. So we want to take our function in the denominator and multiply that by the derivative of the top, or the numerator, minus, flip it, so the top times the derivative of the bottom all over the bottom function, or the denominator raised to the second power. There are a slew of mnemonic devices out there to assist you with this. I'm actually not going to tell you any of them because I like to focus on the conceptual aspect, but feel free to do a quick Google search, mnemonic devices to help with the quotient rule when taking derivatives, and you'll be able to pick from the gamut. So let's say we wanted to take the derivative of this rational function. If you have been able to tell, all of the weird functions are my favorite, like the exponentials, logarithms, and trig functions. But I'll spare you. So we have the denominator times the derivative of the numerator. The good thing is the derivative of e to the x is e to the x minus the numerator times here the denominator, or the derivative of the denominator is e to the x plus 1 over this squared. Okay? And we will leave it as such. Now, it seems like this is a very straightforward process. It is, because we're just computing derivatives. We're not really doing anything mind-boggling. However, if we were to say, find me the points of the tangent line along this function, now it becomes a little bit more time-consuming and cognitively demanding. Okay? So the mechanism is very simple. The application is where things become a little bit more difficult. But that's it in terms of product and quotient rules. It's more so something that you become more skilled at through practice. It's very rote, it's very procedural. Find some problems online, and for my calc kids, you have a slew of suggested practice problems to get to. So, see you in the next video.